Alright, ladies and gentlemen, we are back and better than ever. We are looking at the congruent central angles theorem in this video. So the goal is to be able to identify the congruent central angles theorem and utilize it in some application. So the congruent central angle theorem is actually things that we've already been discussing based on what we know about arcs. Remember our central angles. Our central angles have a vertex at the center of a circle and are made up of two radii. Of course, the radii are congruent in length. And ultimately what we're saying is that if we have congruent central angles, this only works if their arcs, the minor arcs, are ultimately congruent as well. And that just makes sense. If this angle here is congruent to this angle on over here, this two central angles are congruent. Well, if the central angles determine the measures of the arcs, that's how we end up getting, right, the same congruent arcs in the end. But we're going to be talking about specifically the lengths of the arcs, all right, not the degree measures necessarily, what we call arc length, all right, arc length, okay? So let's take a look here at another theorem that's going to help us kind of identify a little bit more about circles in general. And that is just how do we make circles congruent to one another? Well, if you think about circles in general, the only way to make a circle congruent is if they have the same radius, right? Ultimately, that's how we end up creating circles. If you think about a compass, you are using a compass to create a circle. So if I just kind of take a compass here and I have a radius, right? This is the center where my cursor is right now. That is where the quote-unquote center of the circle would be, right? And if I go ahead and extend it on out an arbitrary length to where the pencil is, that's the radius of the circle. And so when I make my circle, that's going to create a unique radius. So the moment that I bring in my radius and I change it, and then now of course the two radii are not congruent, I create a completely different circle. But those aren't going to be congruent circles anymore. So they have to have congruent radii. So let's recap. Congruent radii create congruent circles, okay? Congruent central angles create corresponding congruent arcs, okay? So let's take a look here at a couple of examples of how we can utilize this to do a little bit more of application. So let's go ahead and take a look at a couple of examples. It says, tell whether the red arcs are congruent or not. Well, it says explain why or why not. Now this is where it gets kind of interesting here. So for part A, we have all of these angles and these radii and these what we call sectors in the same circle. So that means they're all a part of the same circle. With that being said, this angle 80 is a congruent central angle to this angle 80, and they are a part of the same circle. So if that's the case, of course the quote-unquote circles are congruent. Therefore, arc EF is congruent to arc DC in this example, okay? But now let's compare that into part B. If you're looking at part B here, clearly you see two separate circles, right? They are circle Q and a bigger circle Q, but look at the two different radii. You have Q to R being a radii of this smaller circle, as is QS, but then you have a radius of Q to T and Q to U for the larger circle. So even though these arcs both have a degree measure of 90 degrees at the central angle, the arc lengths are different because naturally the circles are different sizes. So let's conclude here for part B. What we can say, and if you want to write this down, this might be beneficial, is that even though they have the same arc degree or arc measure, they do not have the same arc lengths because they are a part of non-congruent circles. So let's go ahead and take a look at part C. In part C, two separate circles. However, the key factor is that the two radii are congruent. TV and XZ are congruent radii. Therefore, they are congruent circles, meaning that not only are the central angles of 95 degrees congruent, the measures of arc YZ and UV are also congruent arcs with equal measures. So they are congruent in length and they are congruent in measure, or equal in measure, what I should say. So remember, they have to be a part of the same circle or congruent circles to have equal arc length. Equal arc length.